I believe that is it. All right, hello, boys and girls. We are excited to see you this evening, and we appreciate everybody joining in and participating in our virtual Hooked on Science night. We are so excited about this opportunity. If you ever see Miss Manley, Miss Karen Manley in the hallway, make sure that you give her a shout out and a thank you for bringing Mr. Jason Lindsay on board with his Hooked on Science program for us. She does a lot of work for us, and we're very blessed to have her. So I hope that you will take an opportunity to give her a shout out and a thank you for bringing him on board here. So a couple things before we get started. I am monitoring, as you kind of see me looking to my right, I am monitoring the chat box. So let's make sure that we are keeping it appropriate and that we're not using any foul language or anything of that nature. Otherwise, we will have to uninvite you to the link. So make sure that you are being polite and nice and courteous in that regard. Mr. Lindsay is going to get on here in a minute. He's going to share some fun things for you, and then after the experiment is over, we will take an opportunity to ask any questions that you might have of him. And then he's going to talk a little bit about posting your pictures. So hopefully you'll have an opportunity afterwards to take some pictures of you and your family doing some science experiments at that point. So I am going to turn it over to Mr. Jason Lindsay with Hooked on Science now.
Cool. Hello, Natcher Elementary students. I hope you and your family are safe and well as we continue to battle a vicious virus. We are virtual instead of in person because of COVID-19, but just hang in there. We'll get to see each other in person soon, hopefully next school year. In the meantime, I do need to go over with you a few rules that we've heard since March of last year. Make sure you're washing your hands often. Warm soapy water. Make sure you sing the happy birthday song twice. We should be doing that whether it's COVID season or not. Make sure you're covering your mouth when you're sneezing and coughing. Wearing your mask correctly, it's covering your nose and your mouth, and you're keeping your distance from others that aren't in your immediate family. You've heard them a million times, just wanted to remind you. Some other important rules when it comes to science. Don't eat or drink your science experiments. Make sure there's an adult around and wear the appropriate safety gear when doing science. Now tonight, typically when it comes to virtual science, it takes hands-on science and turns it hands-off. But we tried to stop that, and how have we? You have a bag in front of you, and in that bag you should have some ingredients, including a dowel rod, a spring like this. This was on the side of a notebook, and you should have 2 coffee sleeves. We're going to do some science experiments with those ingredients a little bit later. You'll know whenever I need you to grab them because I'll tell you, I'll say it's time to do a science experiment with me, Mr. Science. But we're also going to do some other things, like pop a balloon with the sharpest thing I know in orange. We're going to do the egg drop, and we're also going to do some other cool science experiments. A little bit about me. I know we've seen each other before, or maybe this is your first year at Natcher and you're a kindergartner and you're logging on and mom and dad's like, who's this guy? I was born and raised in a town you may not know. It's called Bowling Green, Kentucky. Oh, wait a minute. That's where you're at. So I was born in the same town that you are in right now. I went to several different elementary schools, but I didn't go to Natcher, the best elementary school, right? I went to Richardsville Elementary, T.C. Cherry, L.C. Curry, Parker Bennett. I went to North Warren, Warren Elementary. I already mentioned that one. I went to Moss Middle. I went to Warren East Middle and ended up at the best high school ever, Warren Central. Is that what you feed into? No? Yes? I forget which one you feed into. Yes, some of you feed into that or Greenwood, one or the other. So I was a fire-breathing dragon all the way through my 4 years of high school, and I always loved doing science. So I chose a degree in science at Western Kentucky University, to where I studied meteorology. So I live in two parts of the state. I live in Lexington and Paducah, Kentucky. And I'm in Lexington because of the vicious virus. I do the weather here, Sunday night, Monday night, Tuesday night, Wednesday night, at the local ABC affiliate. I'm their interim until we can get through all of this, chief meteorologist, and hopefully that'll happen in the fall of 2021, and then I'll just go back to filling in every once in a while. And then my family and I call Paducah home as well, Quilt City, USA. If you've ever been to the western part of the state, that's one of the bigger parts of the state. When it comes to the biggest city, that's Paducah. So I'll travel back and forth throughout the week, back and forth here and there doing stuff. And then I'm back to doing some in-person science programs as well as virtual. Okay, enough about me. I know you're some of the coolest kids there in Warren County, so let's get to some science experiments. Let's first talk about force and motion. So if you are in kindergarten, raise your hand. If you are in third grade, raise your hand. Those two grades really hit pushes and pulls. A push or a pull is a force. A push or a pull is a force. A push or a pull is a force. Some things require more of a push or a pull. You learned this when you were just a baby in your diaper, when you tried to push the couch and it didn't go anywhere. But you went to the kitchen and you pushed the chair and it went somewhere. It was easier to push the chair in the kitchen than the couch because the chair has less mass. So in other words, more mass, more force. And when you get to middle school, you're going to connect that to the second law of motion. I'm going to go over to the refrigerator here and grab an egg. Wow, there's all kinds of stuff in the refrigerator. It's cookie dough. That sounds good, doesn't it? Eggs, cucumbers. So this is one of the places that I stay at in Lexington. Here's an egg right here. It is a hard-boiled egg? No, it's a raw egg. What do I mean by that? It hasn't been cooked. So let me get a little bit closer. So you'll notice my egg, it has not been cooked. I got it fresh out of the refrigerator. You have your pie pan. That's something else very important. You have your toilet paper tube. And considering the number of people who bought toilet paper at the beginning of the pandemic, you should at least find one of these toilet paper tubes somewhere at your house or at a friend's house. We're going to stack everything up like this. I think I told you that a force is a push or a pull. Some things require more of a push or a pull than others. That egg is going to stay there until something moves it. It's going to keep going until something stops it. It's first law. And then the third law, for every action, there's an opposite and equal reaction. So here's my question to you. How do I get the egg in the glass of water without touching the egg? And by the way, you can't pick up the other pieces either. You'd be thinking about it. It's a good hypothesis. I like it. Hit it. Yeah. Somebody else thinking, what if I pull it? That's a good hypothesis. What I'm going to do is apply a force. We have balance forces acting on this. It's standing. So here's balance forces. I'm standing. Here's unbalanced forces. Whoa, I fell down. So when everything is equally pushing on me, gravity's pulling down, air is pushing equally against me, that's called balance forces. So I'm going to hit the pie pan. So if you try this at home, have an adult around, but don't do it over the couch. Got it? So what I'm going to do is apply the force, and as soon as I feel the pie pan hit the palm of my hand, I'm going to stop. Because if I keep going, it's going to knock everything down. Hocus pocus, are you focused? Eyes on me. 3, 2, 1. And it went right in. Did you see that? Yeah, cool science experiment. When we did this on the Today Show in New York City before the pandemic, John Cena and I did it with 5 eggs, 5 toilet paper tubes, 5 glasses, 1 big tray. Hit the tray, all the eggs fell in. Okay, I think everybody might be on at this point, so I do need you to grab your mom and dad because I need to tell them, or grandma, or grandpa, or aunt, or uncle, or whomever's in charge, because I need to tell them where to go to enter you into a chance to get a free science kit. So by the time I get to one, I need you to go grab the adult that's in charge of you so that I can tell them some important information. 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Eyes on me. You got mom, dad, someone that's in charge of you nearby. How are you, parents? I hope you are safe and well. By the way, I continue to think about you as we all continue to synergize to conquer COVID-19. Your kid could win a free science kit. They're called Ooze Labs. If I have not sent Miss Karen those actual Ooze Labs, I will send them to her soon, okay? She just needs to let me know, send me an email reminder, or give me a call or something. I think I put them in the box, but if I didn't, just let me know. I've done so many of these, I forget who I've sent and who I haven't sent them to. So these Ooze Labs are basically little test tubes that have all kinds of science experiments in them. One may have hydrophobic sand that's scared of water. Another may have instant snow. So how can you win one? All you got to do is make sure you go to one of the Facebook pages, or for that matter, let me pull up an actual graphic here to kind of help you out as I'm talking to you. You got to pull up one of the Facebook pages, or for that matter, you can also go to Twitter as well. Don't forget to like those pages and make sure that you leave your pictures and your comments from tonight. Once you leave those pictures and comments from tonight, my screen may have went black. That's okay. That's me. So Miss Thornhill, don't do anything on your end. That's me on my end. What I'm about to do is actually show you a quick little picture that's going to kind of help you better understand where you can go when it comes to getting this location and all that good stuff. So let me quickly pull that up for you. And then once I get that up there, you can easily go to one of those locations to like Hooked on Science, or for that matter, go post your pictures and all that good stuff. Okay, you should see it right now. Is that up on your screen, Ms. Thornhill, Mr. Thornhill?
Yes, it is. We are live there, and you can see your sites.
Okay, cool. All you got to do is go to one of those pages on Facebook, Twitter, Instagram, like those pages, and leave your pictures of your kids doing some cool science experiments tonight, okay? I'll give you 24 hours to do just that. You will already see a post at those pages with the Natcher Elementary School logo. So be sure to like it and leave your pictures and your comments. The school with the most pictures was, I'm trying to think which one it was. It was the one over by your school district building. You can remind me of it. Briarwood. Briarwood had tons, like close to more than 100 there that they posted. But you can beat them, Natcher. You can post all kinds of pictures. So make sure you go do just that and so on. Okay, let me bring you back to me so that we can show you our next experiment. And it's time for you to do a cool science experiment with me. What I want you to do is to grab 2 ingredients, a dowel rod and this little spring right here, okay? So grab those from your bag. I'm going to count down to 10 so you have it in front of you. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Macaroni and cheese. Everybody freeze. Eyes on me. Good job. So here's what we're going to talk about. We've been talking about pushes and pulls, right? Let's talk about something with 4th graders. And that is energy, the ability to do work. You can't create energy and you can't destroy it. The same amount of energy that was here yesterday, a few minutes ago, here today, here now, we'll be here tomorrow, we'll be here a few minutes later. So how do I get it from one spot to the next? We use the word transform or transfer. So we could use 2 words there, mean the same. We can transform the energy. So watch me first before you do it. I'm going to get a little bit closer to the camera. You'll notice I have my dowel rod. I'm pinching the end of it. What I'm going to do next is slide the actual spring over the dowel rod. You don't do it yet, you're just watching. And I'm going to make sure my finger is not under, or this spring is not under my finger, because I want to be able to pull it back and eventually let it go, and it's going to shoot or launch off of this. So, two types of energy that we're going to talk about here. Potential energy. You can say it with me. Potential energy, that's stored energy. I'm going to store the energy, that's potential energy. And then when I release it, stored energy is transformed to kinetic energy. Kinetic energy is energy of motion. And then it should launch across the room. This is a simple experiment. Stuff them around the house. That's so important. Why? Because it's great that you know that energy is the ability to do work. But more importantly, can you take what you've memorized for a test and apply it in the real world? Or teach someone else? That's how we know you've mastered it. So could you take this and go teach a cousin? Could you take this and teach mom and dad? That's important. That's why it's simple. And you know, moms and dads, I know many of you have transformed kitchens into science labs. 3 important tips as we continue to do this. Make sure you keep it simple. Simple science, okay? Do not split atoms in your kitchen. We don't need that happening. Make sure that you're using ingredients from around the house. For example, an orange, a balloon, an egg, a glass, just about everything here. And understand that science doesn't always work the first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th time. You got to keep trying. Okay, now that everybody's went over this and you've got it memorized, what I want you to do is pull it back and you're going to let it go. Just like that. And I launched it across the room. Do not launch it at anyone's face. Do not launch it at a pet's face. Do not launch it at any living creature's face. Make sure you're doing this toward the ceiling. We want to make sure you're safe. Now, if you do this on your own, I sent you plastic ones for a reason. Do not use the metal ones, just in case if you do accidentally launch it towards someone. I don't want you to hurt anyone with the metal one versus the plastic one. So again, stored energy, potential energy. We're going to transform potential energy to kinetic energy just by releasing it, and it will shoot across the room. I held on to mine for purpose, because while we're just doing this during a family night setting, you could really turn this into a good experiment. So if I take and measure this out into pieces, say 4 equal pieces. And I say 4 equal pieces because you know how many quarters are in a dollar. There's 4 quarters in a dollar, right? So what happens if I go to one of those quarters all the way down and then launch it? And I measure. Will it go greater than if I do a whole with a little bit of tension in there? So you could do a quarter, a half, launch it, measure how far it goes, 3 quarters. Don't go all the way because you want some tension in there so that you can store the energy. If I just let it sit there, not a lot of stored energy, at least enough to make it shoot through the air or launch through the air. So we could do it 4 different times, measure it, and I might have a hypothesis or a guess, and that is more stored energy equals a greater distance. Just like that. Pretty cool. Don't forget, parents, take some pictures of your kids launching that spring across the house. Post them at the Facebook page, Twitter page, as well as Instagram, and I will do a drawing, let you know who won. If you don't have one of those pages, you can go to hookedonscience.org, click on Contact Us, and send me an email. Okay, let's clean up our mess. Grab your pieces, put them next to your side. It's what scientists do. They clean up after themselves. And we'll move on to the next experiment. So I'm going to count down from 10 while you do that. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Clap once. Clap twice. Bottom on the seat. Feet in the floor. Hands in your lap. Eyes on me. 3, 2, 1. This is a pretty cool science experiment. And if you are in the 2nd grade, or for that matter, 5th grade, you're learning about matter. Matter is anything that takes up space and has mass. Matter can exist in 5 states, Kentucky, Tennessee, okay, all joking aside. Solid, liquid, gas, Bose-Einstein condensate, plasma. You're more familiar with the main 3, solid, liquid, gas. You by now know, hopefully, that matter, this bag and you, made up of small pieces. The smallest unit of matter is an atom. You put together atoms and you get molecules. Okay, you're made of small pieces, I'm made of small pieces, Your dog is made of small pieces. Your cat is in the bag. But obviously, your pieces are put together differently than the bag. Okay? Your pieces create a cool kid. Your pieces create a kid that has so much to offer this world. So keep that in mind. I know we're struggling with COVID-19, but we're still thinking about you, whether you're at home or sitting in the classroom. Our thoughts are with you. We're thinking about you. And we still want to encourage you to try your hardest wherever you're at, because you have so much to offer this world. Okay? I look forward to seeing you soon. But in the meantime, remember, we're still thinking about you. So your pieces are put together uniquely to create a cool kid. You're not a plastic bag with water in it. This is an experiment. Once you get back to school, and I hear you are, you can put this up above Mr. Thornhill's head and then jab pencils through it. Who knows? He might have bushy hair the next day. You never know, right? All joking aside, try this over the sink first, then your principal's head. So bag of water in here, it's a liquid. The bag is a solid, and there's a little bit of a gas. And when you think about gas, kindergartners get this confused because gasoline is something we put in our car, our vehicle, but gasoline is a liquid. We abbreviate it and call it gas, but that can be confusing. So a gas is a combination, for example, of gases is something we breathe into our lungs. We need oxygen from those gases. We breathe out carbon dioxide gas. So what I'm going to do is take this pencil, which is a solid, and I'm going to push it through the bag, and it should work. Every once in a while, it will leak out everywhere, depending on the quality of the bag, depending on lots of factors. But overall, it looks like we're staying dry. My feet are dry. Good thing, because there's cords down there. By the way, if you do something like this, don't do it over the computer. Make sure we're protecting the electronic devices. Make sure we're not getting anything wet. Make sure when you take that computer back to school or whatever the device is that it's still working, okay? So when you're doing science, wherever you're at, keep that in mind. So it's not leaking out. The science is simple. The smaller pieces that are holding hands around the pencils that make up the bag are holding hands tight, and it's not letting it leak out. Pretty cool. So you can't see those small pieces, but they're there. You need a microscope to see them. But I promise they're there. Otherwise, we wouldn't have me, we wouldn't have this table or anything else. Okay, let's refocus. 3, 2, 1. We've done all kinds of things so far, and we're not done yet. We've done everything from an egg drop and learned that a force is a push or a pull, that some things require more of a push or a pull than others. We've learned about matter and how it's everywhere, all over the place, how you're made up of small pieces and I'm made up of small pieces. We've learned about energy, which is the ability to do work. You want to do a science experiment with me? And I'll say the last two after that. Let's do that. What I need you to do is grab the coffee sleeves or your hot chocolate sleeve. I mean, anything that's hot, you can put this around and it's supposed to protect your hands. I need you to grab it by the time I get to 1, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Okay, clap once, clap twice, eyes on me. This is a cool experiment because when I sing you this stuff, it's important because it's everyday ingredients from around the house. And it's opportunity science, meaning that, as I told you earlier, great that you can regurgitate that matter is anything that takes up space and has mass. Great that you know that the dew point is the temperature for which a parcel of air becomes saturated due to cooling. Okay, but more importantly, can you take all of this and teach someone else? You'll notice right here I've numbered mine. Can you see that a little bit better? Can you see the 1 on that? I don't know, I can't see. When I turned 40, my eyes went wacko. And then there's a 2 on this one. 1 and a 2. So was one bigger than the other? Kind of looks the same size, right? Don't do it yet, by the way, because you're going to do yours a little differently. Let's do this. I'm going to take this one, and I'm going to set it on top of this one and line up the ends. Okay, do you notice anything? It looks like one is longer than the other. From observation, the bottom one is longer than the top one. Do you agree? Look again. Yeah. So here's what happens. In the 4th grade, a little bit before that, we learned that you and me, we have internal and external parts. So I have eyes, nose, mouth, face, nose, you get it, ears, all on the outside. But then I have something on the inside of my head called a brain. So I collect information through my five senses, send that information to my brain, and then I make decisions. So this is why it's important to make good decisions. So maybe my friend's over here and he says, "You smell like cheese," okay? But maybe he meant to say something else. So instead of me reacting, I might ask a question and then use my observational skills to not react in a way that might get me in trouble. I might say, "What'd you just say?" "Oh, okay, never mind." So see how I stopped, I thought about it, and I changed my behavior. Very important we do that by using our five senses. So looking at this, one looks bigger than the other, okay? Well, what I'm going to do is take the top one and place it on the bottom. Promise we're not doing a magic show, it's a science. So take this one, place it on top. Do you notice anything? So the one that was on the bottom is now on the top, and the one that was on the top is now longer. What's going on here? Okay, put this one on top. Now that one's longer. Okay, you get the point. But look at this. They're the same size. So here's what's happening before you do it. Your brain is taking this arc on top of this one. See, there to there. I could use a ruler to measure it. And it's comparing it to the bottom arc here, which is shorter. So as I put these on top of each other again, our brain is comparing the bottom arc, the top of it, to the bottom part of the top arc. One is longer than the other, and it's saying, "Hey, human, one of these coffee sleeves is longer than the other." But you're like, "No, it's not." You take in more information, you put it on top of each other, you might measure it and say they're the same size. Here's what you're going to do, friend. You're going to take and you're going to open yours up, okay, both of them, and you're going to place them on a table, for example, like this, flat on the table, okay? Place them flat on a table. And then you're going to take and line up the sides to make them equal on one side, and then compare and look. It's better for you to open it up. It's just better for me to handle them and show you with them closed. So I want you to go ahead and try that. I'm going to give you a few minutes to do just that, play around with it. This is one of those things to where you're just with your family. Maybe they're getting a cup of coffee. Maybe they're at a restaurant and you're like, "Hey, opportunity to do science beyond the classroom window." And you teach your parents how it's an optical illusion, or maybe your cousin, your aunt, your uncle, grandma, grandpa. That's how we know you're mastering the science. So you have internal and external parts. We use those parts every single day to do the things that we do. Now, there's some things you don't have to think about, like breathing. Good, right? I mean, I would hate to dislike, hate's a big word. I would dislike to have to think every second that I have to breathe and then do everything else in addition to that. So yeah, some things are voluntary. They automatically happen. Okay, go ahead and clean up your space there. Put your pieces put them back in the bag. And we have two more science experiments. Then we're going to wrap it up with some questions, which will take us to about a quarter till, okay? Quarter till will be, let's see, I'm at 7:26. You're at 6:26, right? Because you're Central Time and I'm Eastern Time. So that'll take us to about 7:45 or 6:45 your time. Okay, and this is one I've had to ban if I do any in person this year, because I have to put my breath in here. But I do have an automatic pump that will pump this up as well, so we're not using our breath at all. But since you're there and I'm here and we're talking to each other through a computer, I'm okay to have my own breath around me. I'm going to inflate an orange balloon. Back to matter. Matter, anything that takes up space and has mass. I haven't forgot about you, first graders. I know I haven't mentioned your concepts yet, but we're about to do just that. I'm filling up my balloon full of air. In first grade, we talk a lot about sound and light. Light travels in a straight line until it hits something. Once it hits something, it can do one of three things: reflect, refract, or absorb. You can see me, right? Because light is bouncing off of me. There's three more important light words that you need to know by the time you get to at least fourth grade and you're tested in science. And that is, there are some objects that light can't get through. Like light can't get through this, okay? It's opaque, by the way. Light can somewhat get through my balloon, okay? Especially as I blow it up. Can you see somewhat? You can see my armpit. Good thing you can't smell it. But you get the point. You can somewhat see it there. That's translucent, by the way. The air in the room, I can see right through it. That's transparent. I'm overfilling my balloon on purpose. I hope it doesn't pop yet, because I'm going to pop my balloon with the sharpest thing I know. And the sharpest thing I know is an orange. Ow, it cut my hand. Okay, maybe it didn't. But if you're a balloon, yeah, it might cut you. Why? Because this balloon, made up of small pieces, we already talked about that. And even on the inside, we have lots of my smelly breath, small molecules of air and carbon dioxide gas and other things, okay? So what I'm going to do is, I could throw the orange, but what if I miss, hit the camera, knock it down, we can't get reconnected? That wouldn't be good, not at all. What I'm going to do is peel some of the peeling off, and then the peeling, it's orange on one side, and it's kind of a creamy white color on the other side. So what I'm going to do is hold my balloon like this, and I'm going to squeeze some of the oil from the peeling. You see the peeling, it contains an oil called limonene. Limonene will take apart the smaller pieces that make up the balloon. It'll act as a solvent. That's a high school chemistry word. You might hit it in middle school. But here's the bottom line. It's taking apart the small pieces. Okay, everybody on the bottom, feet in the floor, hands in your lap, Tootsie Rolls and lollipops. You were talking, now we're not. Okay, here I go. Eyes on me. Squeeze the oil on the balloon. And it popped. Notice they did not touch at all. I squeezed that oil on there and it took apart the smaller pieces. The key to that, if you're going to try it, you can use a lemon, you can use a grapefruit, you can use an orange. The key is to make sure it's fresh, whatever, and the balloon is overinflated, and it works every time, okay? So that's a pretty cool science experiment. Here's something else that you can do with that science experiment. You can do a small balloon, a big balloon, and a medium-sized balloon, and then squeeze the same amount of oil on each one. Which one takes longer to pop? You can measure the circumference of the balloon with a stretchable or obviously you couldn't use a ruler or a yardstick, but you can use one of those measuring things that mom and dad might have in a sewing kit overall that would allow you to stretch it around the balloon and kind of measure it, collect some data. That's how you know you're doing science. You're going through the scientific method. You have a question, create a hypothesis, you design your experiment, you do your experiment, you collect your data, you come to a conclusion. It's like writing a story. You have your intro, supporting paragraphs, conclusion, and so on. Okay, one more experiment. Then we're going to start to wrap it up. Good with that? Okay. So this next one, back to force and motion. I have a bottle here, but this is a special bottle. But it's not so special you can't find it. This bottle here is a juice bottle, and it's overfilled with water. So you'll notice my bottle right here. You could also use a Gatorade bottle or a Powerade bottle, a grape juice bottle, but it has to be strong on the sides. It can't be very flimsy. Let me find another. This one's flimsy. So this glue bottle is too flimsy. This is one of the secret ingredients to creating leprechaun snot, by the way. Leprechaun snot is a pretty cool St. Patrick's Day science experiment. You mix together that and an activator and turn the glue green and you have leprechaun snot. Nothing too advanced, but you get the guide at hookedonscience.org. So I have my bottle of water and I need more water in that. That's enough, not enough water. So let me grab my cup over here and I'm going to overfill it. Can you see the water on top? You can if you look really close. Next, I'm going to take, and then this is a ping pong ball, not a golf ball. I'm going to put this on top, move it around, just like that. Then I'm going to take and slowly turn this upside down. I think Miss Karen said that you could try this above her head, okay? So slowly, slowly. It's dripping a little bit. Oh no. Keep going. Keep going. And voila. Okay, make sure the computer scooted over. There we go. So here's what's happening. It's not a magic trick. It's science. Magicians use science. They call it magic. They do some cool stuff, though. I have lots of magic friends out there. The ball right here, ping pong ball, sphere, water on the inside, pushing down, gravity pulling down, should pull the ball right off, right? It doesn't, though. The reason why is there's another force acting on this ball. That force is an invisible force, and it's called air. It's in this room, it's in your room. If it wasn't there, we'd be in trouble. Got to have air because it contains oxygen. It's pushing just as hard on the ping pong ball as the water is pushing down and gravity is pulling down. What do we call that? Any third graders should know, especially by the time they go into fourth grade. It's called balance forces. Balance forces are acting on this. If the ping pong ball were to come off, that would be unbalanced forces. Unbalanced forces. So I'm going to go back, back, back. And then you're like, you probably glued it on when I wasn't looking. Voila. Didn't glue it on. There's a little bit of suction that takes place there as well. Suction that kind of keeps it on in addition to that invisible force. So in case if you were snoring or sleeping there, I'll overfill the bottle again, create a little bubble on top. Then I'm going to take my ping pong ball, push it down on there, move it around, and then I'm going, then I'm going to turn it upside down, slowly but surely. That's key, by the way. Slowly. There you go. Yeah, I was able to do it. Whatever I do, I can't squeeze the bottle, the sides of it. Because if I squeeze the sides of the bottle, what's going to happen is it's going to give that water a little bit more of a push and push the ping pong ball off. Let's go back around, back around, back around. Remove this, and there we go. So that's a neat one that I like to do. It's a cool one that you can try using everyday ingredients from around the house. Again, moms, dads, grandmas, grandpas, aunts, uncles, whomever is out there, make sure that you are going to the page and you're liking that page, multiple pages, Facebook, Instagram, Twitter. You're leaving your comments. You're posting some pictures there, all that good stuff. I'm going to enter you into the drawing for a free science kit. And so on. I'm checking now to see how many. We got some on there that's posted some, but you got 24 hours. So make sure that you go post those pictures and comments and so on at one of those pages, or send me an email, because not everybody has social media. It's a good thing if you don't. It can be crazy sometimes. But bottom line is, I want to make sure I enter you into that drawing for that free science kit. Don't forget, hookedonscience.org has you'll at least find 2 St. Patrick's Day science experiments there. One called leprechaun snot, another one called rainbow milk. And we're not talking about with your Fruity Pebbles or your Fruit Loops. We're talking about a rainbow. Will there be a pot of gold in your cereal? A pot of sugar, probably, but no gold. And then coming up next week, because we'll be past St. Patrick's Day, it'll be Easter, so I'll teach you how to turn an ordinary egg into a geode. What is a geode? It's an ugly rock on the outside, or at least some people might claim to be ugly, but you crack it open and it's beautiful. We're going to launch a carrot through the air, like a giant carrot, and more. Pretty cool. Now, let's see, what time is it? It's about 36 after. Do you have any questions? Questions start with who, what, when, where, why, how. I am not looking for a story, but a question. Do you have a question for me? I'm going to let Mr. Thornhill kind of guide me. Did you get any questions, Mr. Thornhill?
We're starting to get one. Can you clarify where they need to post their picture? Can it be on any of those 3, or does it have to be on all 3? The Facebook, Twitter?
It doesn't have to be on all 3. If you do all 3, you'll get 3 chances to win. So for each post, each one that you do, that gives you an extra chance to win overall. But you can just do it on one. Look for the post. It looks something like this. It's got your school logo. Can you see that? There we go. It's got your school logo on it. And go look for that and post a picture and a comment in the page there overall, and then I'll do a drawing and let you know. So you don't have to do all 3, you can just do one. Okay. Or if you do all 3, you get 3 chances.
There you go. All right, so boys and girls, if you want to start posting a question or 2 there for Mr. Lindsay in the chat box on the YouTube stream, I will pick one of them and see if we can get him to answer it for you.
While they are doing that, I will go find another experiment. I think I may have the soaring carrot. I can show you a giant carrot that we're going to launch through the air. So I'm going to step right outside here and go to my trunk, which has tons of science in it. It also has a dinosaur. You stay right there, Oliver. We can't let the kids see this dinosaur in my back seat. Okay, let's see. That's not it. Let's see. Let me look over. Oliver, behave yourself. No eating my seat, please. Only third graders eat seats, right? Okay, one more thing that I'm. Oh, there it is, right in front of my face. Okay, let me grab some Alka-Seltzer. Okay, I also have a sample of the science kit that I'll show you as well. So I've got this giant carrot. Oliver's in my back seat, my pet dinosaur. Let's hope he doesn't destroy my car. Giant carrot that I grew in my backyard. Here's the science kits, by the way. They look like this. They look like test tubes, and this one's hot ice crystals, by the way. Okay, I have everything right here. Well, you are asking Mr. Thornhill your questions. So I have a platform. What's in the bottom of this is something neat. So a long time ago, I remember as a kid taking all the film to the film developer. So we would have a camera and we would take lots of pictures. Well, they weren't on our phone instantly, couldn't see them at all. You would just hope you took the picture right. And then later on, the camera actually had a screen on it and you could actually see the picture and delete it if it didn't work out well. But before that, you couldn't really tell if your picture was perfect other than just by taking the picture. And then you would go to the film developer with your film, which you would put in a film canister, and then they would develop the pictures and you would get them a whole week later. Okay. So those film canisters aren't used for that anymore, but they are used for cool science experiments because you can create a rocket. So in the bottom of this, you will notice how I have jammed, not jam that you put on your biscuit, but pushed a film canister in the bottom of my carrot. And then I glued the other piece to the bottom of my platform. So I'm going to try to launch this carrot through the air. I got to add some water. Okay. You think a little bit or a bunch? A little bit? Bunch? Okay. We'll put a little bit. Okay. Next, I'm going to open up my Alka-Seltzer. It's called an effervescent tablet. Let's do one. I don't want to blast through the ceiling. Think it might go through the ceiling? Let's do two. It's not your ceiling, right? Should be doing this at a friend's house. Okay, so next I'm going to drop those in there. Oh no. Next I'm going to snap everything on. That's eye level. I better get out of the way. And there goes my carrot. I just launched it into the air and it shot up toward the ceiling, but it didn't go through the ceiling, so that's good news overall. Okay, soaring carrot. Why did it do that? When you add water to Alka-Seltzer, it fizzes, it bubbles, it creates a gas called carbon dioxide gas. And that gas builds up so much so in the film canister that it launches it up into the air and then through and across the room. That's where all of the gas built up in the bottom of my carrot. Pretty cool. Mr. Thornhill, did you get any good questions?
So I don't have any questions yet coming my way. I've got a couple that are just double checking your website as far as getting on, to do their posts. I will say, you families at home, you can look at Natcher's Facebook page and Natcher's Twitter page that he has tagged us on there, so you can see it from there. I would just ask you, you talked about being a meteorologist there,
Mm-hmm.
and what would be some science skills that you have to use that you learned to help him in that career?
First let me say that, it's great if you want to go to college, but it's also important that you understand if you want to master a trade, like say being a plumber, being an electrician, being a mechanic, it's okay. Not too long ago, the United States did a new study and they included those trades as STEM careers. And the STEM careers that rule America, that are predominant in America, are not doctors, are not engineers. They are those that are tradesmen and women. So the trades actually power STEM in America: electricians, plumbers, dental hygienists. All of these are STEM careers, and you don't go to college as long, you don't have as much debt to pay back, and you can make as much money or more than college degree. So keep that in mind. So with that in mind, I didn't master a trade. I went to school to be a meteorologist, and I use all kinds of science skills, math skills specifically, as we talk about averages for average daytime highs and lows. Even when I communicate temperatures over a trend, I use bar graphs because that's what you're taught in school, and that's what you better understand, because you know the higher the graph is, or higher the bar is on the graph, the more it means. The lower, the less it means. So if I have temperature trend of 65 and it's down here, but 100 and it's up here, you know this day over here is going to be hotter than this day down here. So a lot of that is being able to take the data, which can be hard, and explaining it in a way that everybody else can understand. So that's what we call a science communicator. It's pretty cool. Lots of math, lots of science. I think I had 4 years of calculus at the end of the day. I don't use it all because I don't design the models that we use, but I do read the models. So I need to learn how to read the models. I don't design them. That happens somewhere else, but not on the TV side of the business overall. But yeah, lots of math skills and being able to present those math skills in an understandable way.
All right, good. I'm still just getting clear. I'm trying to clarify where they're posting their pictures. Everybody wants to get their picture posted, Mr. Lindsay.
Okay.
So that's a good thing. They want to get in that drawing, so that's exciting.
Yes.
So I'm helping them with that. But
now the only one that's different than all the others is the let me go to that screen again, is Twitter. Twitter is HOS Mr. Science, and the other two are Hooked on Science. So if you go to one of those, you'll be able to find everything. It looks like several people are starting to tag and post stuff there. Let me look on the Facebook page on my end. We got several more. Let's see, I've got some pictures here from different folks. This one kid, it doesn't show me the name, but it may show me the parent's name, really like the coffee sleeve experiment. So cool. Make sure you post your pictures. You'll have some time. I'll give you 24 hours. So by this time tomorrow, and I will send an email to Mr. Thornhill and Miss Karen and say, hey, these 5 are the winners. Come by the office and pick up your science kit overall. So be pretty simple, be cool. Hopefully we will be able to see each other soon in person. But did you get any other questions there from anyone, Mr. Thornhill?
No, I think we're focused on getting our pictures done. So that's good. Why don't you finish maybe by telling me, like, if you had to choose one experiment from all the different things that you do, if you had to choose one, what would be your favorite experiment?
So my favorite experiment of all times, let me think about this because I've done so many of those science experiments. I like elephant toothpaste. You know, I told you I had a dinosaur in my car over there out in the garage. Not for real, I'm joking. But playing with dinosaurs will be fun, especially if they're an herbivore. I think that would be a neat little experiment. But beyond that, elephant toothpaste. Elephant toothpaste is a mixture of 2 ingredients that I can't tell you because it's dangerous. But once you put them together, it creates a ton of foam that shoots way up into the air. And that foam creates so much everywhere that if an elephant was going to brush its teeth, it would brush its teeth with that foam. So that's why we call it elephant toothpaste. Number 2 would be the exploding pumpkin. To where you carve out a jack-o'-lantern and a pumpkin, the face, put the pieces back in, put another secret ingredient inside, too dangerous for you to try at home, ignite a gas that's created when you add water to those ingredients, and it blows out the eyes, the nose, and the mouth of the pumpkin with a fireball sometimes. What about number 3? I'll give you my top 5. I like the egg drop, but with multiple eggs and multiple toilet paper tubes. My number 4 favorite science experiment, the upside down ping pong ball water bottle trick. That's another favorite one of mine. And then I like the straw worm as my 5th one. Basically, there is a straw in your worm. Wait a minute, a worm in your straw. There we go. A worm in your straw. It's a cool little experiment that you can try. I'll show you the basics because it's another one of those experiments that takes you beyond the classroom window. You'll need a straw like this. It doesn't have to be like this. You could use a McDonald's straw. You could use a Hardee's straw. You could use a Starbucks straw. You could use a Dunkin' Donuts straw. The list goes on. But what you're going to do is you're going to take and squash the wrapper down just like this. So squash down the wrapper, pull off the wrapper, put it on a flat surface. You see it right there. Let me grab a plate over here. Okay. So you're going to put it on a flat surface like that. And then you're going to dip your straw into water, put your finger over the top, then lift up, and you have an eyedropper. Let's see if the worm appears. All eyes on the straw. 3, 2, 1. Did you see that? It's moving. Oh, wow. Oops. I'm sorry, I hid it from you, but you get the point. It moves all over the place, and it talks about absorption. So what do I mean by absorption? You know about absorbing. A sponge sucks up water. It really sucks up the water, and the worm extends. The straw worm extends and gets bigger. So here's the question. Is a Starbucks straw paper more absorbent than a Dunkin' Donuts, or maybe a Hardee's, or maybe a Burger King, or whatever? You could try multiple different straws to see which one can suck up the water the most. Pretty cool. Those are my top 5 science experiments.
That is amazing. Thank you so much for sharing all those. Well, I appreciate you taking time to lead us through all these experiences and lots of rich vocabulary. I love how you connected them to the standards, specifically to even the different grade levels standards. So that was well done there. And everybody on the chat box is saying how much they love science and that you did amazing, so cool, and lots of great praise to you as well. So really appreciate you taking time this evening to show us your talent and love for science, and hopefully we can inspire some kids tonight as well to pursue their passions with science.
Yes, sir. Yes. Thank you so much. You know, I forget, you have 6th graders in you have K through 6, not K through 5, right?
Correct. K through 6.
Yes. They have not moved to middle 6th, 7th, and 8th to middle school yet. Okay. Got it. Yeah. Cool. Okay. Well, 6th graders, you hit the laws of motion. So we hit a little bit of everything from K through 6. Cool. Thank you so much, Mr. Thornhill, and everyone else. Keep safe, keep well.
All right. Thank you, everybody. You'll have a great night. Get outside.